All right, so I'm recording this. This is going to be the food lab practice. So again, in your comp book, we want to make sure everything's labeled so that you remember when and where we did this. So Unit 9, Food Lab Practice. And you'll use this practice to help answer and go through your food lab itself. Okay. So there's some information that was given, and we'll call it our data table. Information that we need to solve these problems. We have the volume of water, the volume of water that we're going to put in the calorimeter, the pop can. We have the food item, and I made up a food item, almost like it's a real food item. I called it cheezy poof. I should patent that. Isn't that a good word? Yeah, I would write it down in your comp book because this is practice. So that way, when we do the lab and you're trying to do the problems, you can refer back to it. Yes. So then food item, my cheesy poof, I need my initial mass. And I need my final mass. I also need to take temperature of the water. So I need my initial temperature of the water in my calorimeter, in the device, in the pop can. And I need my final temperature of the H2O. Remember, we need to solve in our lab MC delta T. So it's really important to take the before and after temperature. And we need the mass, which in this case, because it's in the calorimeter, we're going to use the mass of the water. So on the practice worksheet, I do give you values. I made them up out of my head. I actually only used 60 milliliters this time, just for fun. We've been using 100, but I decided to use 60. I want to give you a reminder, the graduated cylinder is in milliliters. However, we talked about the equivalence to grams. It's a 1 milliliter to 1 gram equivalence. So that would mean that I have 60 grams, which will help with my math. My initial mass that I took, again, this is totally fake. I just made up these numbers, is 0.59 grams. And then the mass after we burn. Here, why don't I put after burning, so we remember that the final mass is taken after you've burned the object, in this case the cheesy poof. After I burned it, I did some calculations and I got 0.38. We'll use the balance basically. Your initial temperature was about room temperature. 2425 is room temperature, so I wrote down 25, but of course you'd be taking that temperature with a thermometer. And then my final, it went all the way up to 51 degrees, all the way up to 51 degrees. All right, so the first problem on the practice asks you to solve for, find the little c calories released by cheesy poof. And from now on, I'm just gonna write CP for cheesy poof. So first of all, let's recognize that this is called a chemical calorie, the little c calorie. I put the line there to represent it's a lowercase. It is not a food calorie. So in the back of your packages of nutritional values, when it says calories, this is not what I'm referring to. I'm referring to a chemical calorie. So it is released by the cheesy poof. So we're going to solve, but when you solve for your MCAT and you're solving for heat, Q or capital Q or capital H, whatever letter you used here, you're actually solving for the heat of water is absorbing. So then you got to remember, you're going to take the opposite symbol, because in this question I've just jumped to the second part, I guess, in the previous parts of when we're practicing. I always gave you step 1, solve for how much the water is absorbing. Step 2, so, and then tell me how much the cheesy poof or whatever item chemical is released. So this one is already jumping to that. So we need to remember to change that symbol, whatever we get here, change it to be negative. All right, so I'm going to plug in the values and use my calculator. I have 60 grams of water that I'm using. I do not add the mass of the actual item because this is in a calorimeter, a metal device. I'm not adding this into a solution. Okay, so this is not into a solution of chemical, this is added into the water. So, or this is in the water directly, just the water. And then I'm looking at my specific heat. Well, we need to now recognize which specific heat value should we use. We want to use the one that's in little c calories because that's what I've asked you to answer it in. That is 1 calorie per grams times degrees Celsius. And then the change of temperature, we take the difference here. So we have our calculator somewhere to be found. All right, so we can use our calculator and we subtract the difference, or we can just do it in our head, to be 26 degrees Celsius. All right, so then I'll take my calculator, multiply 60 times 1 times 26, and I get 1,560 little calories. It's asking me for the amount released, so I will change the symbol, and that would be my final answer. Okay, let's go to part B of the food practice, and it then asks you to find the food calories released by the cheezy poof. Again, that negative is just saying it's an exothermic. It's not giving you a negative value. It's saying that it's exothermic. That's what the symbols represent. All right, so now we need to figure out this little guy. We have food calories, and this is the first time we've seen this in chemistry class. You've seen it in every nutritional box or image that you've seen on anything that you pick up nowadays. What we need to see is what the equivalence of food calorie is. So 1 food calorie is equal to 1,000 little sweet calories. Let's box that in. Again, this is chemical, and this is food. That's how we can relate to that. Chemical and food. So 1 capital C calories is equal to 1,000 calories. So if we had just solved little c calories right here, we could, yes, perfect. And the answer just came up from a student in class. We could just divide by 1,000. So that is just moving the decimal over 3. So then our answer wouldn't even have to do any math here. It would be negative 1.56 capital C calorie. There is. So that's where the question in class was fantastic, because on some of the packages, especially in Europe, you'll notice that the back of your packages don't have calories. The back of your packages have kilocalories or that's the same thing. So it's just a conversion. That's all it is. It's just a conversion. Absolutely right. Good job. All right. The next part asks you to solve for calories per gram released by the cheezy poof. All right, so we now need to figure out how many grams we burned. We can go back to the top with our data table, and we can take the difference between the initial and the final. You subtract the 2, you get 0.21 grams. Okay, so this is how much you burned, or how much you have left, I guess. How much you left, okay. So now we're going to do the calories, so we'll take that, 1.56 food calories divided by 0.21 grams, and we get 7.429 food calories per gram. Again, this value is only there to tell us that this is giving off, right? Released by your food item, in this case, the cheezy poof. When we're going to get to the next and final step is calculating your percent error. This is not a negative value that you input for food. Okay, so when you're in your final step to determine your I'll put it number 2, percent error. So we actually need information from the cheesy poof bag. So just like today in lab, you're going to look at the marshmallow bag and see, just like you're going to look at whatever food item you look and see what the nutritional value that scientists already came up with. The actual or known from the bag reads 150 calories per 25-gram serving. That's what the bag reads. So before we go into our percent error, we need to do a quick little calculation of what is it calories per gram with the known. So we can divide the two, should be an even number. If you can't figure it out in your head, 150 divided by 25 should be 6. There it is, 6. So we have 6 calories per gram. So our known value is 6 calories per gram. Known. All right, let's do our percent error. Your absolute values, known minus your experimental over known. Again, the word known or theoretical, there's different words that are used for the same thing, times 100. So we are going to take 6, because that's the known, minus 7.429. Again, we don't use that negative because that negative is only saying it's released. That's what the negative symbol means here, not a negative value. Divided by 6 times 100. We'll type it into the calculator. 6 minus 7.429 divided by 6. And then multiplied by 100, it's 23.81. And I am not including the negative because it's the absolute value. So then I have 23.8, and I'll round up to 82%. So 23.82% error. Man, were we really good. Our lab was really good. We did not have a lot of heat escaping. Not very realistic in our class, right? We're doing the best we can with a pop can, making a calorimeter. And it's okay to have a high percent. But as you notice, while we're doing it with Mrs. Salkson's data here, we're only getting a 24% error, not even. All right, so I'm going to pause or actually stop my video right now because we're going to go into lab mode.